Okay, I'm going to give you a link at the bottom. I'll give you a link in the info to this incredible Journal of Astrobiology article. I'm making this video as soon as I've heard this news, and what I want to do is to just focus on the photographs and the comments under the photographs. Figure 1, Sol 88. Photographed by Opportunity's left panoramic camera eye. A significant majority of experts in fungi, lichens, geomorphology and mineralogy agreed these may be lichens. Joseph 2016. These lichen-like specimens are estimated to be approximately 2 millimeters to 6 millimeters in size / length, and are similar to terrestrial lichens. Although there is no known geological process which commonly produces mushroom-shaped rocks with stems, it is unknown if these are in fact living organisms. Similarities in morphology are not proof. Figure Sol 37, photographed by Opportunity's left panoramic eye. A majority of experts agreed these may be lichens. Joseph 2016. The average size of these lichen-like specimens are estimated to be 2 millimeters to 7 millimeters and are similar to terrestrial lichens. See Figure 3. However, if these are living organisms or unusual sediments fashioned by the alien environment of Mars is unknown. Figure 3. Terrestrial lichens, ranging from 2 millimeters to 6 millimeters in size. Photos reproduced by permission. Figure 4. Hematite concretions the size of pebbles, marbles and golf balls, the largest 5 centimeters, from Utah's national parks, reproduced with permission, courtesy of Fantasia Mining and Ashley Roach. Figure 5. Sol 257, photographed by NASA's Mars rover Opportunity, Martian specimens resembling puffballs. Some with stalks and shedding what appears to be spores, and the outer cap, lower cup and universal vein that covers embryonic fungi. To speculate further, the thick coats of white material being shed from the sides of some specimens may consist of crustose, and the white powder spore-like material may consist of leprose. It is impossible, however, to determine with a high level of confidence if these are in fact living organisms. Similarities in morphology do not constitute proof. Sol 182. Figure 6. Sol 182, photographed by NASA rover Opportunity. A majority of experts identified these specimens as fungi and puffballs. Joseph 2016. Note what appears to be spores littering the surface. NASA favors a hematite hypothesis. These specimens, however, also resemble hematite. Figure 8. Sol 1145 left versus Sol 1148 right. Comparing Sol 1145 left versus Sol 1148 right, growth of 15 Martian specimens over 3 days. Specimens labelled 1 to 5 and marked with red circles have increased in size. Those specified by arrows, Sol 1148 right, demarcate the emergence of 10 new specimens which were not visible in Sol 1145 left, photographed 3 days earlier by NASA JPL. Difference in photo quality are secondary to changes in camera close-up focus by NASA. The majority of experts in fungi, lichens, geomorphology and mineralogy agreed these are likely living specimens, i.e. fungi puffballs. An alternate explanation is a strong wind uncovered hematite which had been buried beneath sand and dirt. Figure 9. Mars, Sol 2718 versus Sol 2813. The exact cause or identity of this specimen right is unknown, but may represent possible growth of what appears to be a mass bacteria and fungi on the Mars rover Opportunity after 95 Martian days. Photo, NASA JPL. Figure 10. Mars Sol 51 versus Sol 1089. Growth of what appears to be a mass of bacteria and fungi on the Mars rover Curiosity after 1038 Martian days. An alternate explanation is dust and dirt accumulated selectively in this area of the rover. Photo, NASA JPL. Figure 11, Sol 51. Mast cam photo of the interior, flooring and shelter of an enclosed compartment in the rover Curiosity's ChemCam deck after 51 Martian days. Photo by NASA JPL. Figure 12, Sol 1089. Possible fungal contamination or biocorrosion of the interior walls, flooring and shelter of an enclosed compartment in the rover Curiosity's cam deck after 1089 Martian days? Compare with figure 11. Another possibility, chemical contamination or sand and salt, which adhered only to the interior surface? Photo, mast cam by NASA JPL. Figure 13, Sol 1162, rover Curiosity. Experts identified the white specimens as fungi. Joseph, 2016. Figure 14, comparison of an exposed compartment in Curiosity's ChemCam deck. Sol 1089 left, figure 12, with Sol 1162 right, figure 13. If this represents coincidence or contamination is unknown. Figure 15, Sol 820. Green algae, stromatolites, microbial mats, or unusual abiotic sediments? Photographed by the rover Curiosity Mars Science Laboratory Mars Hand Lens Imager, which takes color images of features as small as 12.5 micrometers and at distances between 20 millimeters and infinity, and having a depth of field of 1.6 millimeters to 2 millimeters. Note, specimen A at the bottom center, also depicted in figure 16. Photograph, NASA JPL. Figure 16, Sol 820, specimen A from figure 15. Evidence of bacterial mat or an unusual abiotic sedimentary formation? Photographed by the rover Curiosity Mars Science Laboratory Mars Hand Lens Imager. Figure 17. Microanalyses of a Martian stromatolite top, photographed by the rover Curiosity Sol 506, compared with a terrestrial stromatolite from Lagoa Salgada, Brazil bottom. Highly organized microspherules and thrombolytic microfacies are common to both. Early cyanobacteria typically form voids, intertwined filaments, and layer deformation within stromatolites. It is possible these formations were produced geologically in the absence of any biological influences. So how does it feel to wake up on the first day where we know pretty much for sure that the Earth is not the only planet with life? If you've enjoyed this video, please like, subscribe, comment below, ding the bell, and do all the things that you can think of. Share the video. There's one, I've never thought of that. Please share the video, and thanks a lot.